Eighth graders, this video is for those of you who missed class on Friday, October 27th. First thing I want to point out is that there is a practice test online. This is for practice for the test that is next Thursday on motion. I would like you to give this a try this weekend, and some more questions will be added next week for more practice. Okay, so going up here, first thing we did today was we put some finishing touches on that terminal velocity explanation with your partner, and then your partners handed that in. So hopefully you were working on that with your partners, and if not, you want to make sure that you hand in a copy of that explanation with your terminal velocity graphs on Monday. After that, we talked a little bit about just how we found that terminal velocity. This big, complicated looking formula here was us just talking about what some of the factors are that go into terminal velocity. You do not need to know this formula. Mass, the acceleration due to gravity, so how much gravity is pulling you down, the surface area of the object, the density of the object, the fluid character of the atmosphere, so basically how thick the atmosphere. All of those are variables that can affect your velocity. Once again, that was just to talk a little bit about how terminal velocity really depends on many factors at work. And then we went and tried to find the terminal velocity of the textbook because, as you should have seen, the coffee filter did have a terminal velocity. It was about 1.2 meters per second, depending on your coffee filter. But the textbook kept on getting faster. We couldn't find it because we basically didn't drop it from high enough. So here's our Logger Pro. I believe this is from Mesh 3. Mesh 3 had a lot of really good looking trials. If we look at the purple line here, so follow along right down here, this is a drop from the second story balcony down to the first floor, and it's speeding up to 6.2 to 6.6 to 7, 7.2, and then it's starting to slow down there a little bit as it kind of crashes. Or if we look at the red up here, starts at 3, 5, 5.9, 6.4, 6.8, 7.0, and then it starts slowing down again. So pretty much every line we look at, you can look at the brown and the blue over here as well, it reaches a velocity of about 7 meters per second, and it can't seem to go any higher than that. So that tells us that the terminal velocity, where the line becomes linear, is probably about 7 meters per second for the textbook. And the reason you couldn't reach that in the classroom is because you weren't dropping it from high enough, and that was part of the plan. Next thing we talked about was velocity time graphs. I'm going to type in the notes that we actually took on this so that you can see what that is. I'm going to make this full screen for a second. I've got a handout with these graphs, so you'll want to pick that up on Monday. There's this one, and this one. Those are the three that we went through. A velocity time graph is different in a couple ways from a position time graph. The first way is that the y-axis is measuring velocity in meters per second, and the x-axis is measuring time. That's the same. The velocity is different. It used to measure position or distance in meters. The other difference is that the origin is now in the middle here. 0 is right there in the middle because you can have negative velocities in addition to positive velocities. So the motion of this object, that red line, it's an object that was traveling at 3 meters per second all the way through. So that means it was just constantly traveling 3 meters per second. Wasn't getting faster, wasn't getting slower. And the fact that it's positive, not negative, means that it was going forward or away from the reference point the entire time. A negative velocity would have meant that it's going backwards or towards the reference point or falling or something like that. So I'm going to go ahead and add that bullet point in here right now. So this was moving forward at 3 meters per second for a total of 10 seconds. Let's pull that over here. You can tell moves forward because it is positive. And the next one we talked about is this velocity graph. This object is going forward at 2 meters per second until 5 seconds, and here's the tricky part. goes down. That means if you look at the y-axis, that means the velocity is going from 2 to 1 to 0. So it's slowing down, and a velocity of 0 actually means it stopped right there. And then the velocity becomes -1, -2, -3. So it's actually speeding up, but the fact that it's in the negatives means it's going backwards. So it turned around or changed direction, and it's speeding up going the other way, and then it travels for at 3 meters per second. So if I added some bullet points in here, what I will say is this object moved forward at 2 meters per second for 5 seconds, slowed down, stopped, turned around, and sped up to 3 meters per second, which it traveled at for a total of 4 seconds. Okay, so that one is a little bit trickier to think about how that motion's happening with that graph. And then finally, this graph right here, let's present this again. Velocity time. This graph is starting at -5, so at time 0, sorry you can't see that right now, that little cursor is down there. At time 0, it's traveling -5 meters per second, and then -4, then -3, -2, -1, and then 0. So that means it was going pretty fast. It's getting slower, 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 stopped, and that whole time it's going backwards or towards the reference point. And now it's going 1 meter per second, 2 meters per second, 3 meters per second, 4 and 5. So it's actually getting faster. It's speeding up, and it's going forwards now. So what I would type in here is, what I would type in here is that it was traveling backward at 5 meters per second. It slowed down, stopped right at 5 seconds, and then turned around and sped up going forward. That's what happened with that object, and at the end of the 10 seconds, it's going 5 meters per second forward. So those are the notes that we took, just talking through how to interpret that velocity time graph. And the final thing that you'll see on Monday is we watched the video where Mr. Barkland made a fateful fall. Mr. Barkland takes a spill. The reason I showed this on Friday, there we go, was because we're going to use that in a word problem on Monday. I was traveling at a certain velocity and I decelerated to a complete stop. We're going to talk about acceleration and deceleration on Monday, so I just wanted to preview that, and you guys missed that in class, so I wanted you to see that. That is it. I hope you have a great weekend.